Okay, I'm Jackson. Thank you so much for doing this. I'm back. This will be part 2 of our discussion. You are a college student in Louisiana being taught evolution, and you're giving me the examples of evolution. You said that we have 98% DNA similarity with chimps. Okay, that's where we left off. And that is simply not correct. Okay, it's about 91% similarity. But the DNA code is so complicated that even a 1,000th of 1% difference could be fatal, a change from the DNA. And again, I would point out the similar DNA probably proves a common designer, not a common ancestor. I think if you look at all the writings of Edgar Allan Poe, you would find thousands of similarities. Yes, that's coming from the same mind, perverted and twisted as it was. It's coming from the same mind. That's why, the Telltale Heart has some similarities to his other writings. Okay, well, that's the fact that there are similarities in DNA and even maybe retroviruses, some kind of weakness in the system that allows this to happen, could be, again, from the same designer. It is not evidence. What happens in colleges typically, Jackson, the teacher will impress the students by listing off 20 or 30 or 40 evidences for evolution. Each one on its own will not stand up to scrutiny. Every single one can be refuted easily, which is why when you started naming off all the branches of science that support evolution, embryology, etc., I said, whoa, take these one at a time. No, they don't. But somebody convinced you somewhere along the line that all these similarities and all these branches of science all point to the same thing, and they don't. You're being lied to. You need to get your money back for this degree. So the phylogenetic, there's no phylogenetic tree. It's an orchard. All of the foxes, wolves, coyotes, dogs probably had a common ancestor. That would be one tree, a phylogenetic tree. All of the apples, and there are 2,000 different species of apples now, they might have had a common ancestor, and it was an apple. That does not prove apples and dogs are related. It's a completely different tree. There are 5 different varieties, or species actually, 5 species of giraffe. They might have had a common ancestor, and it was a giraffe. There are 8 kinds of bears in the world, black bear, grizzly bear, panda bear, etc. They probably had a common ancestor, and it was a bear. What we observe in nature and in reality and in science and even in the laboratory, what we observe is everything produces after the same kind. And people would recognize a grizzly bear and black bear and brown bear and panda bear as a bear. It's the same kind of animal. Now, there's lots of differences, and so the Chihuahua and the Great Dane are pretty different. But they're both recognizable to a 5-year-old as being a dog. They're in the same family. I don't know that our current classification system, developed by Carolus Linnaeus, matches God's classification system of kind. It probably doesn't at all places, but I would say somewhere around the family level would probably be better than the species level. So what you're going to do in school, Jackson, they're going to show you a bunch of examples of new species, like there's now, I think, 80 or maybe 100 species of ladybugs, based on the number of spots and the position of the spots and the length of the legs. And somebody got a government grant to study all this, I'm sure. And, okay, there's still a bug. It's a ladybug. That's not evolution. It's not going to even help the evolution theory. It's the same kind of animal. There are no examples anywhere in history or anywhere in the present, or anywhere in the fossil record. There's no fossil record in the fossils. There are no examples of any animal ever producing anything other than its kind. If you want to think it happened or believe it happened, you are welcome to. But see, the evolutionist is demanding that everybody pay for his religion to be taught. And that's the way it is in America right now. All the taxpayers are forced to pay for the religion of evolution to be taught. And if you don't want to pay your property taxes that support your schools, well, then they'll come take away your house. It is absolutely forced on everybody to pay for this one religion. Okay, go ahead. Next point.
Okay, so I'm glad that kinds were brought up, because I think that was mentioned a little earlier, and I was wondering about that, and so I wrote it down, and so I'm glad we kind of came back to that.
Okay.
There was something else I wanted to say, and I forgot what it was, unfortunately. But anyways, oh, that's right. So the definition of evolution is genetic change in a population, Yeah, did that change in population over time?
Well, now, hold it.
Would you agree to that?
No. This is where the problem comes in. You have to define the word evolution. Exactly what are we talking about? Because what they're going to do, Jackson, in school, there are actually 6 different meanings to the word evolution. 6 different levels or stages. If you want to write these down, this will help make it much simpler. Number 1 is cosmic evolution. Where did time, space, and matter come from? They'll say the Big Bang. Okay, what exploded? Where did it come from? And where did the energy come from? And why are there laws like the law of gravity and inertia and centrifugal force and the laws of the pendulum, etc.? Why are there any laws? Where did they come from? So cosmic evolution is a giant obstacle, I think, to those who want humans and strawberries to be related. Secondly, you have to have what's called chemical evolution. According to the Big Bang theory, the Big Bang would have produced hydrogen and maybe some helium. That's not observable, it's just a religious belief, but suppose it's true. Well, how do you change helium or hydrogen into gold, silver, and platinum?
Well, actually, that part has been observed.
No,
the
that's
process of radio astronomy. You can what scientists do. There was a woman in the earlier 1900s, I think it was, and they use these special telescopes, and they look at stars, and they can see that within the stars these elements are being matched. They can see that they're matched together, and that's where Einstein's theory of relativity comes in, E equals mc squared. So a lot of energy, which is what the star is powered by, is produced when you take these hydrogen or helium atoms and you smash them together, and they become, and so it's this teeny tiny bit of mass that produces a huge amount of energy.
Correct, but see, you have a chicken and an egg. You got a chicken and an egg problem here. That's called fusion. What you're referring to. You can't fuse past iron. As far as I've never heard of anybody being able to use fusion to go past iron. And the energy input is phenomenal compared to the result. And so now you have, where did this star come from, which is the third part of evolution, stellar evolution. The stars have to form, and nobody's ever seen a star form. The current estimate, at least the last I heard, was there are 70 sextillion stars that are observable from Earth with the big telescopes. So that would mean everybody on Earth could own about 11 trillion stars to yourself. We see stars blow up occasionally. It's called a nova or a supernova. But nobody's ever seen any stars forming. And
well, actually, there was about 2 years ago, there was a quadruple star burst that was observed. I believe it was, or I remember seeing the article in, was it BBC News, but there was a quadruple star burst that was on record. That's the only one I know of, though.
So you're saying they watched a quadruple star birth?
That's
I
remember the article saying. I don't remember. I have to look up the article.
Yeah, I'd like you to send me that. I'd like to look at that, because I would predict they started with a big star, like Betelgeuse or something, and it broke down into 4 pieces. That is not stars forming from gas.
Here it is. I found an article. This is not the original website that I saw it, but this is okay. Yeah, I'll just send it to you. Okay.
Okay. Yeah, please do. Now, but stellar evolution, I think, is a royal problem, because we've never, to my knowledge, never seen a star form. Certainly, the idea of gases condensing into a solid is counterintuitive to all known physics today. Gases, when you try to compress them, they build up pressure and they expand away from each other. It takes enormous pressure to condense gas. I mean, you got to have an air compressor or something like that. Where's this energy coming from? So, number 3, my point would be stellar evolution, I think, is a giant problem for the evolution, for the general evolution theory. I'm defining the word evolution. Number 4, you have to have organic evolution. Somewhere, somehow, non-living material, stardust, has to come alive. Now, whether it comes in a single cell or a multi-cell doesn't matter. The fact is, there's a difference between living and non-living. And this is not something dead coming to life. It's something that never was alive. All of a sudden, you go from non-life to life. That is a giant step called organic evolution, and there's no evidence of it happening. No, they can't even make it happen in the laboratory. Number 5, if you want to write this down, is macroevolution. Macroevolution is where an animal changes to a different kind of animal. Number 6 is called microevolution. This is variations within the kind. That's what you gave a definition of. That one is actually science. I believe in microevolution. I do not believe it adds up to anything other than that. Dogs may produce a big dog or a little dog, but it's always going to be a dog. So defining the word evolution the way you started to was, I started writing it down, I missed it here.
Change in the gene pool of a population from generation to generation.
Okay, now stop. Right, stop and think for a minute. That means you've already got the gene pool. Genes are incredibly complicated. You've already got this phenomenally complex, the genetic code of any organisms is more complex than probably all the computer programs written by man combined. So the genetic code in one cell of your body, just the genetic code in there, is more complicated than all the computer programs ever written in humanity. So if you want to start with that and say, now we have changes within this code, well, you're down in number 6 on my list. You're taking what's called microevolution, and that happens. Variations happen within the kind for the reasons you've stated. Mutations happen. Radiation causes things. All kinds of things can cause mutations. That's a pretty well-studied topic. But the question is, do these mutations result in some improvement, or are they detrimental? If you could find one that was an improvement, you're back to the question of, okay, who's it going to marry? How's it going to pass this on? And it's an awfully big world, so this improved version has to somehow take over the whole world to spread its genes. So if you got an improved horse, not only do you have to have 2 of them, all the other horses have to die for this to work. So what your definition that you gave is really a classic example of number 6, which I agree, it happens. Microevolution, but it's not any evidence for anything beyond that.
So microevolution is defined as genetic change below the level of species?
No, I wouldn't use the word species. I use the word kind.
I don't really know what...
Nobody's ever given a good definition of species. A dog and a wolf are different species. But they're
actually different subspecies of Canis lupus.
No, Canis domesticus, Canis lupus, Canis coyotes, they are all different species. But they can interbreed. They normally don't, but they can. A zebra and a horse are clearly different species. But they can interbreed and produce a zorse. So the fact that they can interbreed, to me, indicates they probably come from the original kind. The Bible says they will bring forth after their kind. That is, they will produce offspring after their kind. It's mentioned 20 times in Genesis 1 and Genesis 6 and 7. So I agree.
Okay.
I agree that animals can produce. If they can produce, they're probably the same kind. And studying exactly where the border is to define a kind would be a good endeavor for science to follow. But the fact that we don't know exactly what the kinds are in every case, I think we do in most cases, but I think that'd be a wonderful biological pursuit. However, I did not say species. A dog and a wolf are different species, yet they can interbreed. So exactly what is the definition of a species?
Okay. So I looked it up. And right now it says dogs are Canis lupus familiaris, which I thought they were.
Okay.
Familiaris is the subspecies of Canis lupus, which is what our house dogs
are,
and Canis lupus is the gray wolf.
Okay, well, let's take the zebra and the horse instead. Maybe that'll give a completely different species name. I forget what they are.
I mean, those are definitely different species.
Can they interbreed?
Equus, and I don't remember what the zebra is.
I don't either. It doesn't matter. But can they interbreed?
Probably not. I would imagine.
Just type in Zorse, Z-O-R-S-E.
Okay.
A horse and a zebra can interbreed. They don't normally, but they can. You can type in Pizzly, P-I-Z-L-E-Y, a Pizzly bear, a cross between a grizzly, and something else. I forget what they did.
Is it a panda?
I don't remember.
Or a polar bear?
I think it's a polar bear and a grizzly. I think. Okay. Now they're completely different species. Nobody argues about that. But they're the same kind of animal. It's a bear.
Okay. All right. So I guess if we're talking about kind, I guess I want to ask, a series of yes/no questions to kind of figure out what kind means. I mean, this will help. This will help me to understand what kind means.
Okay.
So, I want to ask. So, the house cat, which is Felis domesticus.
Right.
Right. You would say that is the same kind as a lion?
I would say probably they derived from the same kind. Somebody spent years crossbreeding who knows what, whether it was lions or tigers or bobcats or lynx, or there may be 20 or 30 different varieties in the cat family. And I don't know if Noah simply had 2 cats on the ark and they diversified into all of those, or maybe he had 10 pairs of cats because there are 10 varieties in the cat family. I don't know. But today we have bobcat and lynx and jaguar and, I don't know, pick a number. Say there are 15 or 20 different kinds of cats. The domestic house cat, I think, probably was domesticated from something, one of those, and probably would not, most of them would not survive in nature. So that it would be quickly selected against if it weren't for humans babysitting them.
So house cats and lions and bobcats, those are all the same kind, I guess. They're all in these.
Well, I didn't say that, but I think that's a possibility. Or maybe there are 2 or 3 basic kinds of cats that they derive from. I don't know the answer to that. And again, that would be a good pursuit for some biologists to say, okay, can you get a house cat from a lion if you choose through selective breeding? I will guarantee this: you will not get a house cat from an elephant, no matter how many generations you go through. Nor will you get one from a dog. Now, the lion is maybe close enough to do that. I don't know. But
okay.
I did not.
Well, I mean, the lion is. Sorry.
I did not say they're the same kind. I said they might be. The lion, lions and tigers can interbreed, and they get a liger or a tigon, depending which one is the male. They breed both ways.
Okay.
So you can look up ligon, Ligon. Now,
okay.
They normally are sterile, the offspring, just like a horse and a jackass produce a mule, which is nearly always sterile. I think 1 in 20,000 maybe not sterile. But then it'll quickly revert back to one or the other, depending which is the male, I think is how it goes. So the point is, even a horse and a mule or a horse and a jackass are the same kind of animal, 4-wheel drive, leather upholstery, recognizable as the horse family. This would not offer any evidence that a horse and a butterfly are related. But I'd be willing to bet any amount of money you want that your professors believe horses and butterflies are related if you go back far enough in time.
Oh, I'm sure they are.
Okay.
I'm sure they do believe.
Sure. Well, you tell them I said, A, they're welcome to believe that, but they should stop calling it science. B, I will come to your university and debate every professor you've got there at the same time, 20 against 1, on the condition that I get half the time and we discuss one topic at a time. So I'll take on the whole faculty. I don't even know what university it is, but it doesn't matter. I'll take them on.
Okay, well, I go to LSU Baton Rouge if
Okay.
you're ever in town.
No, I'll drive over special for that. I'm only 4 hours away from Baton Rouge. I'll come over just for that. You get it. I tell you what, ask all the professors, will you debate Kent Hovind? They will say no. And then go ahead and get a room. You know, any club on campus can get a room for free. Get the chess club or the drama club or something. Say we want to rent this or get this auditorium, and have me come speak. And I'll have question answer for the whole audience. I'll take them all on.
Okay. Well, so I want to stick with the topic of kinds. I also want to say you want to avoid traffic between 3 and 5.
Okay, no problem. Baton Rouge, do they have driving tests or light at all in Louisiana? They drive like maniacs.
I mean, that's why I miss Shreveport so much, because it's something 20 miles away. It takes 20 minutes to get there. In Baton Rouge, it might take you at least an hour.
Well, you need to come to Lenox, Alabama. We had a car go by yesterday. That's about the extent of our traffic here. Yeah,
okay, so I'm sorry?
Population 35. We love it here. Okay, so the definition of kind, I don't know that I can give you an airtight definition. I think most of them are intuitive and are obvious at first glance to a 5-year-old that a dog and a wolf and a coyote are the same kind of animal. But a 5-year-old would recognize a dog and a banana as not being the same kind. And I don't know how many varieties of bananas there are, but they are still a banana. As I mentioned, I think there are 1,000 species now of bamboo. Okay, it's still a plant.
So if we'll do the 5-year-old test, I guess. If you were to put up a picture of, a house cat, a civet, and a fox, and then a banana, wouldn't the child classify the fox, civet, and house cat as one kind?
I think they would classify the fox, the civet, and the house cat as animals, as opposed to plants. Yes, they would distinguish that, the 5-year-old test. But I think they would distinguish the cat and the civet as both in the cat family, and would say, no, the fox is not in that family. It's not the same kind of animal. It's an animal, but it's not the same kind of animal. I would guess. We got a 5-year-old running around the yard here. I can go grab him if you'd like, and I'll give him the test.
You don't have to do that.
Okay.
Thank you. So civets and the house cat are both in the order Feliformes. Cats are on essentially one family tree with the Panthera and the felids and hyenas and
right.
Felis and hyenas. Yeah. And the civets are on another tree that is closely related with genets and linsangs and all these other more odd, cat-like animals that we don't really see a lot or talk about much. And so you wouldn't say, or I don't know, this is what I'm asking. So would you say that those are all cat kind or not? Or would you say that there's not good reason to say that they're not all one kind?
That's a good question, and as I've said a couple times, that would be a good biological pursuit to determine exactly where is the border for kind. Certainly, species is a real blurry word, and
depending on which definition, I guess.
Well, if they go by reproductive, population, or reproductive possibility, a dog and a wolf and a coyote can all interbreed. A coyote and a wolf can. They don't normally, but they can.
Okay.
A Great Dane and a Chihuahua can interbreed. Yeah, whether they produce fertile offspring is another. You could decide to make that part of your definition. I don't know. The horse and the ass can produce offspring, but it's normally not fertile. The mule is, I think it's 1 out of 20,000 is fertile, but it's normally not. Now, you brought up a flower earlier before I asked you, hey, can we record this conversation?
Oh, yes.
Let's talk about that and tell me what you thought that proved. I've got a picture of it on my screen here for everybody to see.
Okay, so I was just pointing out, I wasn't saying necessarily that this flower proves evolution or anything as far-reaching as that. I was just making a point about mutations, that there are mutations that can increase the viability of organisms. It can help them. There are mutations that I guess you might call beneficial that will help them survive and reproduce and pass on these traits to offspring. And so with the slender clarkia, which was the flower I mentioned earlier.
Okay, let me repeat that for people to look it up. Slender clarkia, like the name Clark. Slender clarkia flower, correct. There's probably hundreds of varieties of that, but I've got a picture of one on the screen.
Is it like purple and pink?
Yeah, the outer is pink, and there's kind of a purple heart in the middle, or a real dark pink in the middle. Now,
sorry?
I could go back to Google and pull up 50 pictures, but anybody can do that. Slender clarkia is a flower that produces a variety of colors, generally around the pink or purple color band, right?
Yes.
Okay.
So there was a slender clarkia that went through one species, I suppose, that went through a genome duplication, and in that duplicated genome, there was a mutation that allowed it to have a larger range of colors in its petals, so that it attracted a larger range of insects because they could see. They were more likely to see the colors of the flower. And I was just making a point about that, showing that there are mutations that benefit organisms in nature, rather than just organisms that are, cultivated by human farmers.
Right, right. Let me summarize the argument here. Certainly, there are flowers that produce a wide range of colors, and some may attract more insects because of their either more vibrant colors, or we're not sure how insects actually see these flowers. Do they get what exactly is attracting them? But okay, so if there's a slender clarkia that is now more vibrant colors or a deeper shade of purple or something, and more insects are attracted that were not previously attracted. So therefore, it has a greater chance of reproducing because the insects carry the pollen to the next plant. I agree. That's probably a good observation. I would point out that it is still a flower. It was always a flower. It didn't turn into anything else. And I don't know that the offspring, this brighter colored flower, is indeed more likely to survive in nature. Did that bring along with it any deleterious things? Is it now more disease prone? Or is there some enemy going to see it now that's going to wipe that out of the gene code because it's more visible? Just like albino animals don't normally survive long because the predators can see them too easily. They lose their camouflage. So I don't know if this flower lost some of its camouflage ability for certain predators that would wipe it out. So if it's true that it happened, and it certainly could be a good story, that maybe this would give it greater opportunity to reproduce. But there may be something we haven't seen yet as far as something, as I mentioned, deleterious, like losing its camouflage or less disease, more disease prone. That would have to be proven in a laboratory, and that would take, that'd be, again, a good field for biology. But it's still a flower. That's not going to turn a single-celled organism to a human over any amount of time.
Okay, I agree. I mean, that wasn't the point of me saying that. I was just pointing out that I just want to get us on the same page because I know
Sure.
that there are some people who think that there's no such thing as beneficial mutations anywhere.
Yeah, okay.
I just wanted to make sure that we were on the same page in that
Well,
regard.
let me give you a qualified yes. I think if you're calling that beneficial mutation, it may be beneficial in a certain environment and not beneficial in other environments. Like the people in Africa that get sickle cell anemia are less likely to get malaria. So they would call that a beneficial mutation. Well, sickle cell anemia is not good. That is, that's like saying if you cut off your arms, you can't be handcuffed. Ha ha. Well, yeah, but okay, I still need my arms, Okay.
Right. And in regards to that, I can come up. I know of a better example of human mutations that are definitely beneficial. It's much better than cutting off your arms so you can't be handcuffed. For example, the LRP5 mutation, which causes increased bone density in this family, and I think it's the American Southwest or the Midwest, one of those, doesn't really matter. But so this family has a mutation in their LRP5, and this mutation has been looked at by geneticists and by doctors, and they don't see any downside to it.
Yes.
This family gets the benefit of increased bone density without, something like, maybe calcium would be leached from some other source, so they would, end up dying eventually or something like that. But that doesn't happen. So what do you think of that one?
Well, that's interesting. If they have increased bone density, it's still dealing with a structure that already exists. It didn't add a bone. It didn't add a wing. It didn't add feathers. It increased the density of the bone. B, this might be an example of getting back something that was lost over the generations. Maybe everybody 5,000 years ago had increased bone density, and we've lost it for whatever reason, and this is an example of something coming back. So it's dealing with an existing code that is modifying. It's not adding new information would be the point. Secondly, I don't think we know that it's a benefit. I mean, increased bone density would mean you're less able to swim. I would think it would harm their swimming ability. All other things considered, they're not going to float as well. So, so maybe it's a benefit for one area of life and not a benefit somewhere else. I mean, birds have hollow bones. It would be a detriment for them to have increased bone density. They don't want that because now they can't fly as well. So, but again, that little example of a family getting a LRP5 mutation, a mutation in LRP5 gene, may indeed be helpful in some circumstances. We don't know. I think it's worthy of more study. But that is such a minor example compared to the big picture. You'd have to have trillions and trillions of these changes proven to be beneficial to change anything to a different kind of animal. Are they still human?
Are they still absolutely?
Okay, so they're still the same kind. So that would be a variation within the kind, which really would qualify, even if it qualifies at all, would be number 6. Well, that's on my list. Okay. You also talked about polyploidy, and I got a picture of that now, if you want to give your example for that.
Right. Well, again, my example with the LRP5 as well as the slender clark here wasn't to show that, you know, these have become some new species of organisms. They're actually, they're observations of new species coming into existence based on the definition of the general biological species concept of species. But I was just showing that these beneficial mutations do in fact exist, and there are other ones. There's the alpha-lipoprotein A1 mutation in the family of Melon, and there's tetrachromatic vision in some women.
Hold on, hang on, Jackson, we're at 30 minutes again. Let me stop. We'll go to part 3, and then I've got people coming to visit me in just a few minutes, and then I got to go to a graduation tonight, so I can do one more part after this. Hang on, let me stop this.